Tony Stark walks into Afghanistan selling weapons. He walks out with a nuclear reactor in his chest, lines of code burned into muscle memory, and the most iconic armor in science fiction ever built by a man alone in a cave. War engineering converted into survival engineering in less than 3 months with scrap metal, made by the same guy who was previously more concerned about which yacht to use on the weekend. But here's the question nobody asks. How much of that suit is impossible, and how much already exists? In the Afghan cave, Tony drops a line that flies right past you in the middle of all the adrenaline. 3 gigajoules per second. Sounds like a fancy number thrown in to seem technical. It's not. That's the output of an entire nuclear power plant, compressed into something the size of a hockey puck. He just built a nuclear reactor in his chest using scrap from weapons he sold himself, with shrapnel in his heart, in a cave. No internet, no coffee. Probably shrapnel in his ego too, but we're not measuring that today. By Einstein's equation, energy equals mass times the speed of light squared. A single gram of perfect fuel would produce enough energy to sustain 3 gigawatts for 9 straight hours. In theory, the math works. In practice, there is no material on the planet that can contain that thermodynamic hell without melting in the first fraction of a second, and the Mark I still uses all of that for a short flight in an improvised flamethrower. The energy is there. The problem is controlling it, and the movie already hints at this in the desert sequence when the suit drops like a raw block of steel hitting the ground. Consistent. Nobody said it was going to be pretty. When Tony gets to Malibu and rebuilds the suit in a multi-million-dollar lab, he makes a mistake any aeronautical engineer would catch on the second test. The same man who rewrote propulsion physics in a cave forgot to check what happens to metal at 9,000 meters of altitude in freezing cold. You know that coworker who solves a massive problem but forgets to reply to the simplest email in the world? Exactly that. At 30,000 feet, roughly 9,000 meters above the ground, the Mark II freezes and falls. Ice buildup on aerodynamic surfaces is a classic aviation problem, taught in basic flight training. Tony Stark, certified genius, billionaire, owner of an aerospace company, simply forgot about it. The reactor holds. The flight systems don't. This matters because it shows something real. In engineering, the weakest link never shows up where you expect it. Even if you're the smartest man in the room, and the room is entirely yours, and you have a pet robot watching over you. Mark III is where the movie does something genuinely smart. Lightweight alloys, refined flight control, coating that withstands atmospheric re-entry, and Tony keeps the old reactor as a backup. System redundancy. Real engineering. The billionaire philanthropist finally remembered that backups exist, something most of us only learn after losing a college assignment because we forgot to save the file. The final battle uses exactly this. By taking Ironmonger to high altitude without anti-ice coating, the rival suit freezes and loses thrust. Tony doesn't win by brute force. He wins because he understands the limits of his enemy's system better than the enemy does. Which is, curiously, exactly what he used to do before becoming a superhero. Except back then, it was to sell weapons and buy bigger yachts. But here's where physics stops being nice, and I need you to pay attention because this is the part where everything collapses in a very satisfying way. Picture a tank round, 5 kilograms of metal traveling at 1,000 meters per second. If that connects with a suited-up Tony Stark, weighing around 200 kilograms total, he accelerates to 25 meters per second in less than 1 millisecond. That equals 2,500 times the force of gravity acting on the body all at once. No human bone survives that. No internal organ survives the deceleration. Even if the suit stays completely intact on the outside, the armor protects from the outside in, but inertia acts from the inside out. On the organs, the brain, the blood. The suit is incredible. The body is the bottleneck, always has been. And no amount of money, charm, or sarcasm fixes that. And Tony tried all 3 simultaneously at several points in the film. In the real world, in 2026, wearable jet suits developed by companies like Gravity Industries reach 85 kilometers per hour for 6 to 8 minutes using 5 microturbines and a lot of fuel. Zero arc reactor. Tony Stark solved that by being fictional. We're still trying to solve it as engineers, which is clearly the inferior approach, but unfortunately the only one available. From Mark I to Mark III, the film builds a surprisingly honest engineering trajectory. Absurd power, increasingly refined controls, and the constant reminder that technology runs into the human body before it runs into physics. If you made it this far and still haven't subscribed, drop a like now. It really helps the channel grow. Turn on notifications so you don't miss the next release. And tell me in the comments, which limit do you think engineering will break first? The battery or biomechanics? See you next time.